Hello, wonderful math students, and welcome back to our Unit 3, in which we've been looking at fractions. The lesson yesterday was just an introduction to fractions, where we learned some vocabulary you hear with fractions, how you can write a fraction from a picture, how you can make a picture from a fraction, and then we did a little comparing fractions. If you have not already watched that lesson, make sure you watch that video before you watch this one, because we're going to be using some of the stuff we learned yesterday to help us out with what we're doing today, which is on something called an equivalent fraction. Before we jump into these, remember we had said yesterday that we're going to start including like 2 review questions at the beginning of each of these, just to make sure you're not forgetting all the wonderful things you've learned. The first review question is a word problem, which says Matea's class is going on a field trip. She rents 3 buses and 2 cars. Each bus can hold 40 students and each car can hold 5 students. What is the maximum number of students that can ride in a bus or car to go on the field trip? All right, so for this one, if she rents 3 buses, each bus can hold 40 students. So to find how many students are going on the buses total, that would be the 3 buses times the 40 students on each bus, which gives you 120 students on the buses. Now there's also cars. She rents 2 cars. Each car can hold 5 students. So we would want to figure out how many total students are going in cars by saying, well, there's 2 cars times 5 students in each car. 2 times 5 gives you 10. That means there are 10 students going in the cars. To find how many total students, what's the maximum number of students that can go? Well, 10 could go in cars, 120 could go in buses. So that means the maximum or the total amount of students that could go is 10 plus 120, which would be 130 students. The second review question, what fraction is that? Well, we learned this one yesterday. Remember, when you write a fraction, there's 2 numbers. Your numerator is how many counted parts you have. In this picture, that's going to be how many are shaded. There's 1, 2, 3, 4, 5 shaded. Your denominator, or that bottom number, is how many total parts are in that whole. So in this whole circle, there is a total of, well, this is 5 plus 6, 7, 8. So we get, that is the fraction 5/8. Now that you've got that brain thinking about math, we can jump into what we are looking at today, which is going to be on how you find something called an equivalent fraction. So we're going to be looking at finding equivalent fractions. Before we get into what that is and how you do that, I've got pictures here. Just focus for a second on these first 3 pictures. I've got pizza. I've already got the pictures labeled with the fractions. So we've got, this is half a pizza. This is 2/4 of the pizza. This is 4/8 of the pizza. Just looking at those first 3 pictures, I want you to go ahead and tell me, what do those fractions have in common? Okay. I've heard a lot of different things with these. I've heard they're even numbers, these last 2. I've heard the top number's always smaller and the bottom numbers are always larger, which are all good observations. The main thing that these 3 have in common, though, especially if you're focusing on the pictures, is that they're all the same amount of pizza, right? If I've eaten this much pizza, you've eaten this much pizza, and Denise has eaten this much pizza, yeah, our slices are different sizes, but we all ate the same amount. All of these are just straight down the middle. They're all really, at the end of the day, half a pizza. The fractions look different because the fractions are showing how many total slices it's in. But at the end of the day, these are all just half a pizza. Now, in the idea of they're all half a pizza, they're just written a different way and they're cut up a different way. See if you can come up with another way to slice that pizza where the amount we're looking at is really just half a pizza. So I've given you half a pizza. What's another way you could cut it up besides 1/2, 2/4, 4/8, where it's half a pizza? right? Again, there are a lot of correct answers for this. Usually what students have me do in class is they say, well, it's already out of 2, it's 4, 6 is missing. We've got 8, but 6 is missing. So usually we try cutting it up into 6 slices. Could be a little harder because remember, all the slices need to be the same size. But if you wanted to do 6, it would look something like that. Could be worse. But we would have 3 6. 3 6. That said, there are tons more options. You could have done 3 6. You could have done 5 tenths, 6 twelfths, maybe 8 16ths. I've gotten that one before in class. And there are so many more. So I'm going to stop writing them all because it could go on and on. But there are tons of different fractions we could write, where really at the end of the day, it's just half a pizza. Now the reason we're talking so much about pizza and all these different ways you can cut up half a pizza is because these are all examples of what we're talking about today, equivalent fractions. Equivalent is just a fancy word for equal. These are all equal fractions. They all represent the same amount of pizza. The numbers are different, the fractions are different, but the amount they represent is equal. So this next slide here is a space for us to put that definition. You are taking notes on vocab. This is for sure a word you want to write down. 2 different fractions that represent the same amount are called equivalent fractions. And remember, our objective today is on finding equivalent fractions. So now that we know what equivalent fractions are, we can go ahead and talk about these two and say, well, now that we saw before 1/2 and 2/4 are equal or equivalent fractions, what about these two? Are these two fractions equivalent? What do you think? Well, it may be tempting because before we said 1/2 and 2/4 are equivalent fractions, but I changed something here. Notice the whole pizza and these two pictures are different sizes. This is maybe like a large pizza and this is small pizza. Are these two fractions equivalent? Well, are those two amounts of pizza equal? Well, no. If I ate half a large pizza and you ate half a small pizza, that's not the same amount of pizza. When you are talking about two fractions, it is important that the size of your whole, so that means here it's the size of that circle, it's important that the size of your whole is the same. And we saw that some in our lesson yesterday when we were comparing fractions. Remember when I said if you're drawing 1/2 and 2/4, remember that that whole, that shape you draw has to be the same size? This is just a reminder of that. It's not equivalent unless this shape here is the same size. So 1/2 and 2/4 that we just looked at a moment ago. Whoops. Nope. Going the wrong way. There we go. These two circles, those pizzas, are the same size. So we can say 1/2 and 2/4 are equivalent. But here they are not the same, which means those two fractions are not equivalent in this example. Now that we've talked about that little reminder about how they need to be the same size, we can go into these here. So for these problems, it's asking me to write the two equivalent fractions. So I'm looking at two circles here. I see that the circles are the same size. And if I'm looking at them, they've already got some shaded in green. I see for here, that green part starts here and ends here. And then over here, even though it's cut up into more slices, it's still the same amount of green. It starts here. If I'm thinking like a clock, it starts there at 12 o'clock and then stops right there. So if I focus on that shaded color, that green part, it's the same amount of green. So what are those two fractions? Well, over here, we've got 1, 2, 3 parts out of 1, 2, 3, 4, 5, 6, 7. So 3/7. And I've got 3/7 is equal to 1, 2, 3, 4, 5, 6. So over here, there are 6 parts shaded. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 total. So before we had a bunch of examples of fractions that were equivalent to 1/2. We had 1/2, 2/4, 3/6, 4/8, and so on. These are another example of equivalent fractions. 3/7 is equal to 6/14. Now it's much easier to come up with these fractions that are equivalent if you've already got a picture where it's all shaded in for you. Something like this, 4/10. I wanted to figure out a fraction that 4/10 is equal to. You can use pictures. So if I wanted to find what 4/10 was equal to, I could use this picture to represent 4/10. Now I see it's already in 10 parts, so all I have to do is color in 4 of them. I'm going to do the same thing they did. I'm going to start kind of like right here, if you're thinking like 12 o'clock on a clock, and color 1, 2, 3, 4. This right here represents 4/10. Now over here, even though it's cut up into a different amount, I still want to have the same amount shaded in. So just like I did here, I'm going to start in the same place and I'm going to color in parts until the same amount is shaded. So for here, I could color in 1. That's not going to be equal. And 2. And that is the same amount shaded. It is very, very helpful when you're doing this to start in the same amount and shade the same direction. Start in the same amount, shade the same direction. If I had been trying to color down here and then over here, it's going to be harder to see that they're the same amount. But if I start in the same part and then color this way, it's much easier to see that 4/10 is equal to 1, 2 over 1, 2, 3, 4, 5. Now, maybe you've noticed, maybe you've not, but there is a relationship between the numbers and the fractions. There's a pattern, you could use that word. If you have not noticed it yet, that's okay. I've got 2 problems similar to this one for you to try. As you're doing them, see if you start to notice a relationship. So the 2 that you are going to do, the first one is right here. I want to know 4/8 is equal to what fraction of this circle? And then the second one for you over here is 6/8 is equal to what fraction of the circle? Well, for this one, 4/8 looks like this. That would be equal to this, which is 1/2. Over here, 6/8 equals all of that shaded in. That is equal to, I'm going to shade the same amount, which is all of that. And for this one, that is, oh boy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 12/16. Now down here, it's the same question I asked a moment ago. What do you notice about the relationship between the numerator and denominator in equivalent fractions? Remember, numerator is the top number, denominator is the bottom number. Do you notice a relationship between these numbers and these numbers? Or these numbers in these numbers? Usually at this point, someone in class notices a pattern. I'm going to start with this one. Someone usually starts with one of these ones with the fact that, well, this number doubled or multiplied by 2, and this number is also doubled or multiplied by 2. So to get from here, whoops, not with that marker. To get from here to here, all we're doing is multiplying by 2, and we're doing the same thing on the bottom. We're multiplying by 2. Well, is that what happened over here? No. If I'm starting with a smaller number in this one, 1/2, it's not doubled, it's multiplied by 4. Multiply by 4. Down here, it's the same idea. Multiply by 4. What about those last ones we did? Well, back here, we had the fractions 3/7, and this one was 6/14. Well, here, same idea. If I'm starting with a smaller number, times 2 times 2. It's the same thing. Over for this one, we had figured out 4/10 was equal to 2/5. I start with a smaller one. Here it is again, times 2. Same thing, times 2. Now, both of these were multiplying by 2, but in that last one we had over here, it was times 4. But what I hope that you can see, if not earlier than now, is that you can use multiplication to find equivalent fractions. If I multiply both of these numbers by 4, I get 4/8. If I multiply both of these numbers by 2, I get 12/16. The idea of using multiplication is going to help us when we don't have a picture. I could give you something crazy like 4/8 is equal to what fraction over 600? Oh my God, I don't want to be drawing that with circles, but you could use that idea of multiplication to help you get there a lot easier. Now, that's what we're going to do for this next part. So I've taken away the pictures now, but it means that we can still do this. We're just going to have to use that trick with multiplication. If I want to calculate the fraction equivalent to 2/3, and I'm telling you I want 6 in the numerator, we're going to have to use that trick of multiplication. I'm going to look at it and see, well, what would I have to multiply 2 by to get 6? And then whatever that is, just do the same thing on the bottom. Well, 2 times 3 gives me 6. We're going to do the exact same thing down here. Well, if I'm multiplying by 3 on top, then I need to do the same thing on the bottom. And 3 times 3 gives me 9. That tells me 2/3 and 6/9 must be the same amount. You could always, if you want, confirm with a picture. So if I was doing 2/3, I'm going to draw a rectangle because they're so much easier than circles. I'm going to draw 2 rectangles that are the same size. The first one, 2/3, would look something like this. 6/9 would be, not sure how well you can see that on camera, but 6/9 would be 1, 2, 3, 4, 5, 6. And notice they've got the same amount of red. It means those are equal fractions. Remember, with equivalent fractions, the numbers might be different. Here the numbers are getting bigger, but the amount is the same. They have the same amount of rectangle shaded in. These are just smaller numbers and these are bigger numbers. If we keep going with that, 4/5, what would I have to do with 4/5 to figure out what that missing number is? Well, to answer that question, you need to look at 5 and 10 and see what you have to do with 5 to get 10. I know that 5 times 2 equals 10. Once I figured that out, I'm just going to do that same thing up here. So I'm going to do 4 times 2, and that will tell me that missing number is 8. These two down here for you to try. Go ahead and try this first one. 1/2 is equal to 3. It would be 3/6. This one here, I have left it up to you. You figure out any fraction that is equal to 5/6. Well, since I've left it up to you, you can multiply it by anything. If you multiply both these numbers by 2, we would get 10/12 is equivalent. If you multiplied them both by 3, you would get 15/18 is equivalent. You can pick whatever number you want as long as you're using that same number for your numerator and your denominator. So I could pick 100 and get that all of these fractions are the same amount as 500/600ths. You're just splitting up a pizza into 600ths. Those are very small pieces, but these are all the same amount. Now notice for all of these, we were using multiplication to find that equivalent fraction. Instead of making numbers smaller, if I wanted to go the opposite way, what would I need to do? Well, the opposite of multiplication, the opposite of multiplying by 2, is division. If I wanted to go backwards, I would be using division or dividing by 2. Dividing by 2. That's going to be what we do in this last part, which is on simplifying fractions. Now, we have heard that word simplify before. I used it in that lesson on exponents and square roots. And we said in that lesson, simplifying something just means making it simpler, making it easier to think about, easier to look at, just more simple. Simplifying fractions means to write a fraction as simple as possible. So earlier we had looked at a picture of 4/8 of a pizza. And usually when I have this picture in class, students will very quickly point out, well, 4/8 of a pizza, that's just the same thing as half of a pizza. If you're thinking that same thing, you are automatically simplifying a fraction. Why would we want to say 4/8 of a pizza when it's so much easier to picture in your head half of a pizza? That's why we simplify fractions. So one way you can find equivalent fractions is with multiplying, but more commonly we're trying to make fractions more simple. More commonly we are trying to simplify fractions. And to do that we use division. The way you simplify fractions is you take a fraction like 4/8 and you find any number that you can divide both 4 and 8 by. Has to be the same number. So if I'm looking at those, I know 8, I can divide 8 by 8, but I can't divide 4 by 8, so it's got to be the same. I look at 4 and 8, maybe I notice both 4 and 8 you can divide by 2. Awesome, let's do that. Let's divide both of those numbers by 2. If we do that, 4 divided by 2 is 2, and 8 divided by 2 is 4. By dividing by 2, we have found that if you have 4, and I don't know if these lines are clear enough for you, but we have found that 1, 2, 3, 4/8 of a pizza is the same thing as 1, 2/4 of a pizza. Same amount of pizza, just a different fraction. Maybe you're looking at 2/4 and you notice, hey, we can divide by 2 again. If we do that, 2 divided by 2 gives you 1. 4 divided by 2 gives you 2. And we get 1/2 a pizza. Remember when we said back at the beginning, this is really just half a pizza? We can show that mathematically with division. Now one last thing. Maybe you were looking at 4/8 and I had told you in order to simplify, you have to find a number you can divide both of those by. I said maybe you're thinking 2, but there's another option. You can divide both these numbers by 2. You can also divide both of them by 4. If I were to do that, what would we get? Well, 4 divided by 4 gives you 1. And 8 divided by 4 gives you 2. Ha! 1/2. Same thing. If you pick a bigger number to divide by, it's going to get you to that most simplified answer faster. There's nothing wrong with using smaller numbers. It just might take an extra step. But once again, we get the same thing, that 4/8 equals 1/2. Now, similar to what we had said last time, when I said when you multiply the fractions by a common number, the numbers in the fraction get bigger, but the amount of the fraction stays the same. Similar idea here. When you are simplifying fractions, let me erase all of this to make it look nicer. When you are simplifying fractions like this, the numbers get smaller. What's happening to the amount of pizza though? The amount of pizza is staying the same. The size of the parts, or that's weird, the size of the slices is getting bigger for sure, but the actual total amount of pizza is the same at all times. Just because the numbers are getting smaller doesn't mean the amount of pizza is getting smaller. So that's what it says down here. Important, when you simplify fractions, the numbers in the fractions become smaller, but the size of the fraction, so the amount of pizza we have, stays the same. That'll be important to help you consistently picture these amounts, right? Even though the numbers are getting smaller, they're all the same amount of pizza. So to practice simplifying fractions, we've got, this first one says simplify the fraction 15/20. Similar to that last one about pizza, in order to simplify, we want to find a common number that you can divide both 15 and 20 by. What is that common number you think we can divide by? Some numbers you might have thought of first maybe were 3. I know I can divide 15 by 3. 3 is no good because I can't divide 20 by 3. Maybe you were thinking 10. I can divide 20 by 10. Can't divide 15 by 10. 2, can divide 20 by 2, but not 15 by 2. That common number you can divide both of them by is 5. I can divide 15 by 5, and I can divide 20 by 5. Has to be the same number that you're dividing both times. When I do that, let me divide by 5 and see what I get. 15 divided by 5 is 3. 20 divided by 5 is 4. So we get 3/4. Now, one of the things students sometimes struggle with when it comes to simplifying fractions is, how do I know when I'm done? In that last problem, we divided by 2. Remember how I did it twice? How do I know if I can keep dividing or not? Well, the answer to that question is, can you divide more? What could you divide 3 and 4 by? The only number you can divide both 3 and 4 by is 1. And if you tried dividing by 1, what would you get? Well, 3 divided by 1 is 3. 4 divided by 1 is 4. We get the same thing. So you know you're done when the only thing left that you can divide both of them by is 1. If all that's left to divide by is 1, you don't actually have to do it like I did there. You can just say, final answer. That's as simple as it gets. We've got simplify 24/30ths. We've got 24 over 30. This one's got a couple options. What's something we could divide by? This one you could say I'm going to divide by 2. They also both are divisible by 3. You could also divide them both by 6. Remember, the larger the number you choose is, the quicker you get to your answer. The biggest number I can divide both of those by is 6. So if I divide both by 6, 24 divided by 6 gives me 4. 30 divided by 6 gives me 5. 4/5 is as simple as it gets because 4 and 5, the only thing I can divide them by is 1. So we get that as our final answer. Now, if you said something else instead of 6, maybe you said 2, there's absolutely nothing wrong with dividing by 2. 24 divided by 2 is 12. 30 divided by 2 is 15. Notice it's different. If I've got 12/15ths, there's still something else you could divide them by. This one is not done. You can divide them both by 1, but there's something larger you can divide them by. You can also divide both of these numbers by 3. So in order to simplify, we would have to keep going. I would say, okay, now let's divide them both by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. And now we're done. We've got 4/5, just like we've got down here. It is not necessary for you always to find the largest number. Sometimes when those numbers are really big, it's good to start small. If I gave you something like 64 128ths, a lot of people aren't going to know the biggest number that goes into both of those. So it might be helpful to just say, well, they're both even. Even numbers you can always divide by 2, and just start small and divide by 2. Keep dividing by 2 until you see something bigger, right? If you're wondering about this one, the largest number you can divide both of those by is 64. But a lot of people aren't going to know that, right? So you could start by 2 or 3, something smaller, until you finally get it all the way simplified. Both methods are good methods. So keeping all of that in mind, there are 2 here for you to do. The first one says, reduce the fraction 6/9 to its lowest terms. That is just a fancy way of saying simplify 6/9. Reduce it to its lowest terms, make the number smaller, simplify them. All right, that would simplify if you divide both by 3, it simplifies to 2/3. The second one for you, Denise notices that 30 out of 60 students got an A on last week's math test. What other fractions could be used to describe the part of students who got an A? All right, there's a lot of different ones you could say for 30/60ths, depending on what number you're dividing by. You could divide by 5 and get 6/12. You could divide this by 2 and get 15/30. You could divide by 10 and get 3/6. The most simplified way though, and the easiest one to think of besides all of these, is this simplifies to 1/2. It is so much easier for me to say Denise notices half the students got an A than Denise noticed 6/12 of the students get an A. That's why we simplify fractions. It's easier to picture. Now there is one last example for simplifying fractions, and that is this one right here. Simplify the fraction 4/2. Well, similar to before, for halves, I want to find what's that number we can divide both of them by. And I see the number 2. I can divide 4 by 2, gives me 2. And I can divide 2 by 2, that gives me 1. So I get that fraction there. How do we read that fraction? 2/1? Well, remember that denominator tells you how many parts there are. If that denominator is 1, it means there's only one part. It means it's not split into parts. It means it's not a fraction. It means it's whole. I would probably read this to myself as 2 wholes, meaning you have 2 whole amounts. If you have a denominator of a 1, we don't need denominators as 1. 2 wholes is the same thing as just 2. I think this is easier to think of with a picture. That denominator being 2 means that your whole amount is divided into 2 parts. So if I was using a circle, it means what we're talking about is in halves. 4/2, I've got it in halves. But if we have 4/2, it means I've got more than one circle. I've got 1/2, 2/2, I need another circle. Here is 3/2 and 4/2. Well, if I asked you how many circles are colored in, you wouldn't say 4/2 of a circle. You wouldn't say 2 wholes of a circle. You would just say 2 circles. Circle number 1, circle number 2. The point of this example is to show you when that denominator is 1, you don't need to write 1. 2 wholes is just 2. 10 wholes is just 10. 100 wholes is just 100. We can just take out that denominator of 1. So keeping all of that in mind, this last one here is for you to try. Let me erase those circles. And you are going to simplify the fraction 12/4. All right. Well, when you divide both of those by 4, you're left with 3/1, 3 wholes, which is just 3. Thank you so much for watching this lesson on equivalent fractions. Hopefully you're feeling better about fractions every day. What we're going to be looking at tomorrow is adding and subtracting fractions, which we use all of this fun stuff we learned on equivalent fractions today. So get excited. Bye.